In today's video, we're going to look at how atoms can form covalent bonds by sharing electrons. And we'll also see all the different ways that we can draw these covalent bonds. To very quickly recap, we've already seen how some atoms can form ionic bonds by transferring electrons from one atom to the other. This makes oppositely charged ions that are then attracted to each other through electrostatic forces, which hold them together. And the reason that they transfer these electrons is so they both get a full outer shell. Now, this works great when one of the atoms has too many electrons and the other one has too few, like with sodium and chlorine. But what about when we have two non-metal elements, like two chlorine atoms? Well, in this case, both of them need an extra electron to get a full outer shell, so giving electrons to each other isn't going to help. Instead, what they can do is share some electrons, and as each atom needs one extra electron, they each share one of their own, so that together two are being shared, and they each get one extra. The way that we've drawn this is called a dot and cross diagram, and when you do these, you need to make sure that you draw one of the atoms with dots and the other with crosses, so that we can tell which electrons belong to each. Also, even though we've only drawn the outermost shell of each atom here, you might sometimes have to draw all of the shells. Just make sure you check the question to see what they want. An easier way to draw covalent molecules, though, is with a displayed formula, where we just write the chemical symbols of the atoms and use lines to join the atoms that are covalently bonded together. The great thing about these is that it's easy to draw big molecules that would take too long or be too complicated to draw as dot and cross diagrams. For example, this here is a molecule of sugar called glucose, which you don't need to know about specifically, but you do need to be able to recognize that this is a displayed formula. The downside of displayed formulas, though, is that they don't show you anything about the 3D shape of the molecule. For this, we can use a 3D model, which tries to show how the atoms are actually arranged in real life. For a slightly harder example, let's try to draw the covalent bonding in ammonia, which we just saw. It has the molecular formula NH3, so we can tell that there's one nitrogen and three hydrogen atoms, and the first step is to draw all of these out. In our example, we'll only draw the outermost shells. The next step is to think about how these atoms can fit together so that all of them have full outer shells. Remember that because this is hydrogen